What is up, everybody? In this video I'm going to be explaining you about binary tree data structure. You must have heard about arrays, linked lists, stacks, as well as queues, which are linear data structures. Now trees are hierarchical data structures. Now let me explain you properly using my PowerPoint that I've created for you. I'm just using it as a whiteboard. So this is my slide, and I'm going to use it to explain you what binary search tree is, binary trees, and then slowly we'll move towards binary search trees as well. Now the topmost node of a tree is called the root. Now let me first talk about what a tree is, what this binary tree is. So I've just copied the definition from Wikipedia. So if you Google search binary tree, this is what you get. In computer science, a binary tree is a tree data structure in which each node has at most two children, which is referred to as left and right, left child and right child. So there will be a node, and corresponding to each node there will be a left child and there will be a right child. Now what does that mean? Let us say this is 26, and let us say this is 1, and let us say this is 7. So this is a tree data structure. So I can say that this is a tree, and it can even have some more children. Let us say it has 71 as well. In that case, it's not a binary tree, it's just a tree. So for a tree to be a binary tree, it should have only at most two children. That's it. And if it has three children at any node, then it's not a binary tree. Now the topmost node is called the root of the tree, and the elements that are directly under an element are called its children. So for a tree, this was the root, and 1 and 7 were its children, 7 being the right child and 1 being the left child. Now I have an example tree over here that I'll be using. This example tree, I'm just testing my pen also to see if it's working or not. So let us say that this is the root of the tree. So 2 is the root of the tree, and 5 is its right child, and 7 is its left child. Now for 7, 6 is the right child, 7 is the left child, and for 2 we can say null and null are the left and the right childs respectively, both are null. So for example, if A is a child of F and F is the parent of A, then I can give an example here. Let us suppose 7 is the left child of 2 and 5 is the right child. Now I hope the tree data structure is clear to you. Now let me move towards why we should use this tree data structure. So let me write it down here. Why trees? Why should you use trees? We have arrays, we have linked lists, we have stacks, we have queues. Now why should one be interested in learning about binary tree data structure, or let us say tree data structure? So one reason to use tree is or might be because you want to store information that naturally forms in hierarchy, like folders in your drive. So if you have C drive, and inside your C drive you have some folders, let us say Windows, then we have say drivers, program files, and then inside Windows we can have System32 and some other folders, and inside System32 we can have some important stuff that is like 13-14 GBs, if you know what I mean. Important stuff, or virus, we sometimes call it virus. So what am I talking about? Let us just leave it and let me show you what I'm talking about. So this naturally forms an hierarchy. Inside C there will be some folder, inside that folder there can be some more folders. So if your files or your nodes naturally forms an hierarchy, then you might be interested in using this tree data structure. You cannot use arrays or linked list conveniently to let us say represent this kind of data. So now another reason to use binary tree is, let me jot it down here for you. So we can say that this one reason can be reasons to use tree data structure, or let us say trees. Now one reason can be if the data naturally forms an hierarchy. Naturally forms an hierarchy. Forms hierarchy, HIERARCHY. Okay. Now, for example, I already gave you an example of files on one's computer. Now, another reason to use binary trees can be for quick search. Binary search tree. So we'll be seeing how search is made quicker using binary search trees. So we'll look into this. And another reason to use tree data structure can be like a linked list, and unlike arrays, trees don't have an upper limit on number of nodes, as nodes are linked using pointers. So we can say that we have a choice of changing the size. So this is one of the there are n number of reasons to use tree. These are 3 of them. And let us talk about applications of trees. Now, applications of trees include manipulating hierarchical data, as I already told you. Then we can make information easy to search, and then we can manipulate sorted lists of data, or as a workflow for composite digital images for visual effects and router algorithms. There are a lot more other applications of trees, but let me just talk about binary trees and why we should use it. We've already talked about it. Let me now tell you how we can represent it in a programming language like C. So let me add some more slides here. I'll add some more slides here, and I'll talk about why, or rather how, to use trees in C. And let me be specific here: binary tree. So if you want to represent binary trees in C or C++, I personally use C++ for its due to its object-orientedness. So a tree is represented by a pointer to the topmost node of the tree. So let me draw the tree here. So let us say it's 2, let's say 7, it's 9, and then 17, and then let us say 9 or 91. Okay, now let me tell you one more thing. The keys should not repeat in a binary search tree that we'll be looking very soon, but here keys can repeat, so don't hesitate to keep a 9 once again here. So let me tell you one more important concepts. Suppose this is it. Let us say that this is a tree. Then we'll have to link these pointers to null. So these pointers will be pointing to say nothing, null, 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 null. So this is our tree. Now let us say I want to use this structure, this tree, and I want to use it to say I want to represent this tree in C++. How should I do it? Now I'll create a structure or a class in C++. Let us talk about structures, since we can make structures in both C and C++. So first thing that I will keep is data. Second thing that I'll keep is pointer to left child. And then third thing that I want to keep is pointer to right child. Why so? I'll tell you. So now we can say struct. Let me write some code for you. Let me tell you how to implement it. Struct node, and then we can say int data semicolon, and then struct node star left and then struct node star right. This is the pointer to the left and this is the pointer to the right. So let me close my structure here. Now this is going to store a node. Okay, so this is a structure that is representing a node. Let us say this is my node and this is the root node. Let us say it contains 2 as its key. So data will be equal to key, which is 2, and then I have a pointer that will be pointing to some other node, and I'll have another pointer which will be pointing to some other node, which will be the right child of 2. So this pointer will point, this pointer is this pointer is this, and this pointer is this. Then simultaneously we will be creating such nodes for other consecutive nodes as well, and this is how we represent simple tree in C. So I'll be showing you some code, and I hope you like this video. Let me summarize everything. So tree is a hierarchical data structure, and main uses of tree includes maintaining hierarchical data, providing moderate access, and insertion delete operations. Binary trees are special cases of tree where every node has at most 2 children. So now we can say that this is the basic of binary trees. I hope you like this video, and let me know in the comment section if you like this video and if you want some more videos. So I'll see you guys in the next video. Thank you so much for watching.